right, tips and tricks for us to be better and do better in HSC Physics. Talking about here runs alongside these two publications, which are there to support the books that you might have and the notes that you might have through the Year 12 Physics course to get the best possible outcome for you. Okay, oops. Okay, so tips for examination success. And there's a few key areas here to address. At the foundation of everything you do is knowing your syllabus. So the knowledge and understanding and the working scientifically areas are critical. All of the dot points are critical to your success. I'm a big fan of some sort of traffic light system as being a way of you, I guess, starting with how well you know the syllabus. So if you can go through it perhaps with a green, an orange and a red highlighter and use those as a way of saying, okay, this is fine. I understand this. I don't need to look at it again. To this is something I probably need a little brush up on. And this is something I need to go back and really get to know much better from scratch. And that's a good way of then focusing your attention on the areas of syllabus that are going to be the greatest value add for you, which of course is to address the things that you know the least about. Once you have gone through and classified them as green, orange and red, you really need to then go and spend the time to get to know them better. So that's making notes and reading them, but more of that later. Knowing those Nessa verbs is also going to be really critical for your success. So understanding what each of those verbs means and being able to address them effectively in your question. The verbs are there for a reason, so addressing them effectively is critical to writing a good response with the knowledge that you have from that syllabus. Okay, studying and making your own notes. And there's research that strongly supports the idea that making notes, not just copying things out, but actually making notes is really a significant part of a sort of a cognitive process that enables you to remember and understand the material better. And when I say making notes for physics, those notes should contain equations, label diagrams, graphs, tables, flowcharts, important scientists that are part of the syllabus. All of those things, as they're appropriate to the syllabus, are going to be critical to you making notes. And how you do this really is up to you. I've had people who've made their own booklet. I've had people who've made it on an iPad so they can sort of cut and paste in charts and tables that they might not feel so confident about creating themselves. One of my daughters did it on palm cards, the entire physics syllabus, with the syllabus dot point on one side of the palm card and the notes on the other. It's really a matter of finding something that works for you in that space and something you're going to be able to utilise as a tool for your study. Understanding what a band 6 looks like, and you should be striving for the top band in all of the questions that you do. And then even if you fall short of that in some areas, you're still going to be aiming for the stars, if you like. And then obviously practicing is critical, and using that knowledge and understanding. And to get the most out of that practice, you're going to do it under timed conditions. So you put yourself under time pressure. Ideally, you're doing the whole thing in 1 3-hour block. And so you're really building up that fitness, that stamina to be able to concentrate, be able to write, be able to process information for a full 3 hours. So when your HSC comes around, you're able to do that as effectively as possible. Once you have done one practice paper, then marking those responses using marking guidelines or allocated marking criteria, and finding out where you've lost marks. Is that, predominantly in a particular topic? Is it a particular style of question? Is there a particular skill, like reading the question carefully, that has been something in which you have lost your marks? And then you're going to spend some time between that paper and the next practice paper revising the relevant content or brushing up on the relevant skills. Okay, in terms of those Nessa verbs, these are not all of them. The extensive list is available on the Nessa website, but these are certainly the ones that are going to come up most frequently, and the ones in which you need to be most proficient at. And you can see there that there are variations in the way in which those verbs require you to show your knowledge and understanding. And what I would strongly suggest is in your work, you have a strategy that enables you to structure your response in a way that's appropriate to the verb itself. So often, for example, in a compare question, you might break that down into similarities and differences. And the differences sometimes you might be able to put in a table, and that might mean you're writing less and your work is more obvious to the marker. So what you're distinguishing those two items from is more obvious to the marker. Likewise, for an explain question, often you'll be able to break that up into a cause and an effect and use that to scaffold your response. And again, really, ultimately, you're helping the marker to access the information you're providing in the best possible way. Look down to things like an assess. You're going to make some sort of judgment, justify, support an argument. So becoming familiar with those so that when you read that as part of the question, you're able already to start to think about how you're going to structure your response appropriately. These are the performance band descriptors for a band 6, okay? And you'll see the use of the word extensive, and depending on the mark value of the question, you need to think about what's going to show an extensive knowledge, okay? Things like communicating with scientific understanding, succinctly and logically as the second dot point there. So designing and planning investigations that are going to be accurate, reliable and valid. There's another skill area that you're going to need to showcase accurate, reliable and valid qualitative and quantitative data. So being familiar with the expectations here and aiming to meet those expectations in the work that you do, the revision work you do, is going to guide you towards the best possible outcome. Working scientifically skills are also available on the NESA website. There are 7 key skills. It's worth considering, and it's often overlooked by students, it's worth considering that it's stipulated by NESA that about 60% of the assessment marks should come from working scientifically skills. So these sorts of skills are often woven into questions that are also going to test your knowledge of the theoretical aspect of the syllabus, but they'll do it under the umbrella of a working scientifically skills. So problem solving, communicating, tabulating, making predictions, planning investigations, analysing data, all key areas that you should be hopefully proficient at. All right, now during the actual exam itself, there's a whole lot of strategies that you can practice and on the day implement that are going to take your body of knowledge and skill and all that hard work you've put in and maximise the return you get for that. And this is really an area that's quite critical and can make a significant difference in your performance. So using the reading time effectively, you might have wondered why there is a reading time. And I know many students, use it in a range of different ways that perhaps aren't as productive. But if you can be effective in your reading time, you can give yourself an advantage in that. So I'd suggest having a look over the marks, the questions that have the marks that are worth, say, 9 and 7 particularly, and just let them settle in your subconscious. The advantage we have there is sometimes some of that processing of information goes on behind the scenes without us really thinking about it. And when it comes to looking at it again, you've already got some ideas that have been primed by your subconscious in that area. Okay, cast your eye over the unfamiliar stimulus, and this will be a feature of your HSC exam. They will present you with things you've never seen before. So again, by looking at those things and letting your subconscious work out what they're for and what they're telling you, you can be better prepared when you do come to that question. Planning the order in which you do the examination at this stage is a good idea as well. And a lot of students feel obliged to do it from front cover to back cover. And I would strongly advocate that you think about doing it in a different order and that you practice doing it in a different order and find out what works best for you. Certainly the multiple choice is not a really good place to start. And I know some people are uncomfortable with that idea, but I would suggest to you putting pen on paper and doing working is better than starting with the multiple choice. And if you do want to start with the multiple choice, I'd strongly suggest you do the first 6 to 10, then go away from it and come back to the others later. Okay, and I'll get to the reasoning behind that shortly. Second key thing is stay relaxed and make sure you're using your time effectively. Being really agitated and stressed can often impede your ability to use your time effectively. You've got 1.8 minutes per mark, and what you should be constantly doing is just evaluating the amount of time you're spending on questions. So there's 2 key things here. Don't spend too long on a question. And so, for example, if it's worth 2 marks, you shouldn't be spending 5 or 6 minutes writing a wonderful response, because you can't get 3 or 4 out of 2. By the same token, when the question's worth, say, 7 marks, you've then got 12.5 minutes. So that actually gives you time to make a plan. And that plan can help you to structure a response that's of greater value. You might write less and get more for a well-planned response. And so the time taken to do the plan can be of value. And again, this is something I'd strongly advocate you practicing in the lead up, so you can find out how much planning is appropriate for those questions for you, because it'll vary from person to person. The multiple choices, that the HSC and NASA try to put the multiple choices in an order from easiest to hardest. Now, they're not always a perfect order, and obviously that'll vary, what their perfect order is from person to person. But the later multiple choice questions are quite challenging, and often there's 5 or 6 or 7 minutes worth of work for a 1-mark question. And I would strongly suggest, if time is an issue for you, if you have found that to be the case through your practice papers, I'd strongly suggest you leave the last half dozen multiple choice till the end of the whole examination, because there's only 6 marks bound up there, but there might be 25 or 30 minutes worth of work. And that time might be more valuably spent earlier in the paper. If you do end up pushed for time, you can still guess 6 questions. And if you get lucky, you might get 2 or 3 right and have only lost 3 marks in that process. Okay, so that's a really logical, sensible way to approach that. As a marker, I would say that one of the worst things is students who write way too much, and often in doing so, they waste their time and risk contradicting themselves and therefore losing marks. And it's writing succinctly is one of the things that was in the band 6 descriptor. And the way in which you can often write less is by using diagrams, using subheadings, using dot points and appropriate abbreviations to reduce the volume you are writing. And this will make your response clearer, ensure that the bits of your response that are of significant value are more obvious to the marker. Don't forget to write neatly, okay? Things that cannot be read cannot be marked. And so if you're writing illegibly, and I've seen plenty of work that I have been unable to read and it cannot be marked. And that's just a waste of that ability and skill that you've spent the time accumulating. Read the questions carefully, and there's a formal process which I'll unpack a little bit further through this presentation that we are advocating that would be a good way for you to do this. You might already have a strategy, in which case that's fine, but the questions are written in a particular fashion. The verb needs to be addressed, the words are there for a reason, and you need to engage with and unpack the stimulus that's there for a reason as well. So take the time to read questions carefully. In our surveys of student marks lost in trial examinations, the most common reason that students find they've lost marks is because they didn't read the question carefully. So they failed to answer part of the question, or in the rush to unload the knowledge they felt was related to the question, they've missed something and therefore they're not answering the question that was asked. They're answering a question that they have imagined instead. And of course, you can't access the top marks if you're not answering the question. Use the mark allocation to have a think about what are they going to be looking for in a question worth this many marks. So the requirements in a response for a 3-mark question are going to be vastly different for those in a 5 or a 6-mark question. You should be using those marks as a clue as to how you're going to unpack that question and write an appropriate response for it. The structure of your response is really significant. And again, that's a way of presenting your information in a way that's most suitable. Think of it as you're trying to sell a car or you're attending a job interview. The way you present that car will determine how much money you're going to get if you sell it. The way you present yourself in a job interview will determine, to some extent at least, your likelihood in getting that job. And it's the same with a response. If you can structure it effectively, if you can present it well, then you're just improving your chances of accessing the top marks for that. And we'll get to that process a little bit further down the chain of PowerPoint slides. Remember, you should never leave a question blank. Anything you can write that's relevant that hasn't been already written in the question will gain you a mark. Okay, and so that's the instruction that the NESA markers are given. So engage with the question, write down something that relates to the question that isn't already in the question, and at least, even if you don't have the time or the knowledge to do more, you've not given up all the marks on that question. Okay, and that's really critical. You should never be leaving a blank question. The language that you use, you would have seen in the Band 6 descriptors that language is critical, and the language of the syllabus and the language in which the question is written gives you a clue as to the way in which you should be using language in your own response. Okay, and if you can write in a fashion that uses the language that the syllabus uses and the question uses, then you're likely to be using the sort of language that the marker hopes the answer is written in as well. When we come to quantitative questions, which will probably comprise somewhere around 20 to 30% of your HSC examination, make sure you convert your data into SI units, write that data down, use your data and formula sheet to choose an appropriate equation, show all your working, and present that answer with the units that are required. And I'm inclined to think if you've got a calculator and you've got a data and formula sheet, there really aren't many good excuses for not getting all of the marks in each of those quantitative questions. And if you can do that, you're going a long way to having a successful HSC. All right, back to that notion of that cube, and that stands for circle, underline, box, and elaborate. And this is a way of making sure that you have read the question and unpacked it in a way that's going to enable you to respond effectively. So the C of cube means circling the verb. Okay, so those verbs we listed earlier were there to choose from. Underline the key physics concepts. So what the question is built around. If you're underlining the key ideas in there, then you know you need to address those in your question. Put a box around important information. So that might be little clues that are given to you in the question that are going to be critical to understanding the situation that's being described to you in the question. And make sure you elaborate to an appropriate depth for that question. The other acronym that was there was ALARM, which is about a matrix for learning and responding. And essentially, it's about this sort of escalating hierarchy, if you like, of complexity. So idea is you should be addressing the identify aspect of the question. So start with a naming and defining. Now, if the question is only an identify question, then you've addressed that. If it's a deeper question, a question that requires something further up that hierarchy of verbs, then you've laid the foundation, and then each subsequent step lays another part of that foundation that takes you towards answering the question effectively. And then you follow that process and you stop at the area where the allocated verb suggests. Okay, so that's a way of ensuring you're going to answer to an appropriate depth, but you're going to include all of the detail that's required of that response along the way. Let's have a look at some questions. These ones have been teased out of the 2021 HSC paper. What I'd like to do is just share with you some ideas about interpreting that question. I do hope you go away and have a go at these questions in some context later on, and then have a look at how the markers were looking at that question and what the sample answer looks like as a way of helping you to get a gauge on the sort of standard of response that's being looked for. So this first one is a quantitative question from that paper. The first part of the question wasn't relevant to this part B, but it gives you some data here about Mars and the length of a day on Mars. And the question is about a satellite launched from the surface of Mars into an orbit that keeps it directly above the position. So the key information here for you that's in the words of the question is that idea of keeps it directly above a position on the surface of Mars. And that should direct you to the syllabus dot point, which is about geostationary satellites. So knowing that it keeps it directly above a position on the surface of Mars suggests to you that the satellite has the same period of orbit as the period of rotation of the Martian day. That then enables you to utilize this information about the length of the Martian day that is below in your response. Now that is in hours and minutes. And so my tip earlier was to, when you're dealing with quantitative questions, to ensure you convert to SI units, standard international units. So you're going to convert that to seconds in order to process that data. And the question talks about calculating the orbital radius. So if we've got the mass of the planet, we've got T, the period of this orbiting satellite, and we're trying to find the radius. So I've got 3 bits of data. We then look on the data and formula sheet in order to find an appropriate equation. So over the page here, we've got the solutions, and you can see the equation there is Kepler's third law. R, T, and M, the other bits are constants. So the data should have led you to this equation. You'll notice here there's the process for converting the hours and minutes into seconds. And then that data here has been substituted the constants and the mass of Mars to give an answer with units. Okay. Now, typically in a calculation question, as long as you've got an equation and a substitution, and you've worked towards an answer, you're going to get full marks in that question. Okay, so you can see in some ways that's a relatively quick way to earn yourself 3 marks, as long as you had that clear vision from the outset that the information given in the question was about the period of the satellite. Okay. Moving on, we've got a few longer response questions here, and I chose them all because they have some features that you will notice in the 2023 HSC examination. So here's a question. This is what we call a cross-modular question. So you can see we've got a power source and a couple of coils of wire, solenoids in other words. But the question requires not only knowledge from module 6 related to this, but it's also about the motion of the carts. And so it's bringing in aspects of module 5, and also modules 1 and 2, which related to motion from your year 11 course. So there's quite a bit there. There's an introductory little paragraph up here. There's a diagram that needs to be digested, and then there's the question prompt itself. Okay, so we've got these 2 solenoids. They're the same. They're on a cart with wheels, so that suggests that these are able to move, and there's no mention of friction, so you would assume that essentially it's a frictionless situation. They'll move under the influence of a force. The solenoid on cart 1 is connected to a power source. There's this device here, which is a galvanometer. That's what the G stands for, and a similar setup, but without a power source on the second cart. So the hope there for students to be successful is that you would look at this situation and know that as soon as this was connected, a current would flow through the solenoid. That current would cause a magnetic field to be created by that solenoid. This other coil, which is a complete conducting loop, i.e. a closed circuit, will experience that changing magnetic field, change in flux, and as a consequence, we'll get an EMF induced in that CART2 solenoid as well. The nature of that EMF will cause a current. The current will create a magnetic field. The magnetic field will interact with the magnetic field of CART1, and that'll cause a situation where there's repulsion between the two magnetic poles. That will cause a force to be exerted on CART2 by CART1, and by Newton's third law, a force to be exerted by CART1 on CART2. Both carts will move. We're given this information here, and that earlier reference to the fact that all the words of the question are relevant. The mass of CART1 is twice CART2. So they'll exert an equal and opposite force on each other, but the acceleration of CART2 will be twice that of CART1 because it's got half the mass of CART1. It's an explain question, so that gives you a clue as to the level of detail that's required in your response. You'll also notice it's worth 7 marks. So this is not a straightforward question. There's an opportunity for you there to explore the concepts here quite deeply. They tell you a little bit more about what they'd like. In your answer, refer to the current in the galvanometer and the initial movements of the carts. So in terms of unpacking that question using that CUBE acronym, there's a lot there for you to take on board. And this is a classic question where I would suggest your first minute or two, perhaps even 3 minutes, you're making a plan. So you're running through that process conceptually as I did, jotting down some notes, some small points or abbreviations, and then you go back and look at those and think, okay, what order do I need to put this in order to address this question effectively? Being an explain question, it gives us that opportunity to do a cause and effect analysis. Cause, current flows through solenoid of CART1, creates a magnetic field, CART2 experience a change in flux, and then you can start your effect and you can explore what happens in CART2 in terms of current and motion of both those carts. Okay, so quite a lot there. It's a lovely question, and it brings in quite sophisticated physics in an unfamiliar situation, as mentioned earlier. If we have a little look at the criteria, this is what's provided to the markers. And so in essence, you'll see that to access the top marks there, we've got a comprehensive explanation. So that's that extensive band 6 level of detail there. Provides details of the current in the galvanometer and the movement of the cart. That's what the question asks for, and a comprehensive explanation of the observation. In other words, you can give reasons for these details as to what's happening in the section above. We've got a cascade of marks below that for responses that are of decreasing depth of detail and quality and correctness. If we come down here to the sample answer, you'll see, I won't run through that with you, and this is accessible for you on the NESA website anyway, but you'll see that we've got essentially the information that I outlined in that blurb when we were looking at the syllabus earlier. There's quite a lot of key scientific language that's used in there. So things like magnetic flux, Lenz's law, Faraday's law, Newton's law, polarity, deflection, repulsion, and so forth. So that's the sort of language that we would hope you are accessing in order to respond effectively. And you can see for 7 marks, that's a fairly succinct response. So it doesn't require the writing of reams. If you have a plan, you're able to keep your response short and structured effectively. All right, moving on to the next question. This is an interesting one, I thought, because it relates to an area of the syllabus where scientific modelling is of particular relevance. And I've split this up just so it fits the page a little bit better. But again, we've got quite a bit of stimulus there, and it take the time to invest into understanding exactly what that syllabus is telling you. So to run through it with you, we've got a fixed end and a piece of elastic that's being pulled. The idea there is you will know that the elastic will stretch. The elastic has markings placed on it at regular intervals. The ruler is there to support your understanding that those are spaced evenly, if you like, along that piece of elastic. Then we're told a student pulls it and extends it, and the new values of D1, D2, and D3 are measured. See that the stimulus there is suggesting to us that the distance between the first dot and the second dot has doubled. The distance between the second dot and the third dot has also doubled, so that stretching has been evenly experienced across the band. How does this help us to model Hubble's discovery of the expansion of the universe? What Hubble observed was that essentially all objects in space, all distant galaxies, were moving away from each other. So it wasn't so much that everything was moving away from a single point, but that the distance between each distant galaxy and each other distant galaxy was increasing. And so there's a theoretical aspect of the syllabus there that they're asking you to show your knowledge of, but they're doing it under the umbrella of this simple experiment that's used as a scientific model to aid understanding. And again, here's an unfamiliar situation that's used to test knowledge. And this sort of thing is where we can anticipate that your HSC Physics exam will need you to expect the unexpected in that regard. So to have a knowledge set that is sophisticated enough that you have the flexibility to respond to something like this. And again, 5-mark question, you've got 8 minutes really to form your response, and taking some of that time to really understand what the stimulus is telling you and what the question is asking you to showcase your knowledge of is more important than putting pen to paper as soon as you see the question. Okay. So again, I'll be brief with the marking criteria and sample answer, but you can see that the marking criteria doesn't have an enormous amount of detail. So essentially, the markers have to make a holistic judgment about the level of sophistication of the response, the level of understanding of the concept from the way in which you're expressing yourself. 5 marks, the solution or the sample answer there has provided that information in about 5.5 lines, okay? Along the lines of what I spoke of earlier about those observations of distant galaxies. So don't fall into the trap of thinking that writing more is better. It's about taking the time to plan to write effectively. And finally, onto this lovely question. This was a 9-marker from last year's paper, and there's in fact 2 separate pieces of experimental stimulus. This first experiment you will recognise as being a double slit diffraction and interference experiment, and an interference pattern that's produced on the screen for experiment A. And the second experiment is a schematic diagram of a photoelectric effect experiment. And please notice that you've got quantitative data that's been provided to you in both of these experiments. And so the expectation is for you to do quantitative analysis. So going back to that point that was made earlier, that all of the parts of the question are there for a reason. They have given you numbers to work with in the anticipation that you will use those numbers in your analysis. Okay. So 2 separate experiments that you're expected to be familiar with, and some data that relates to each of those. The question, however, is about these results supporting the 2 different models of light. So your knowledge of the syllabus should lead you to a place where you understand that light can be considered to be a wave, or light can be considered to be a particle, and that both those models actually coexist. It's not like one is correct and replaced the other. So we've got a piece of evidence that suggests a wave behaviour of light in experiment A, and we've got a piece of evidence that suggests a particle behaviour of light in experiment B. Okay, so 9-mark question, thinking about the level of detail that you would have to incorporate in that to write a comprehensive response to this question. you'll notice again at the very last part of the question, it says in your answer, include a quantitative analysis of each experiment. So that's manipulating those numbers, using the equations on the data and formula sheet to find additional data that you can use that supplements your response. So, criteria there. There's the word comprehensive again that we saw in that band 6 descriptors. Okay, comprehensive quantitative analysis. So that's a full use of equations and full use of that data to peel out all the relevant information, and then a comprehensive understanding of how these results support the two models. So to show you've got a high level of knowledge of the two models and how each of these two experiments can provide support for those respective models. So the sample answer isn't huge, but have a look at the structure that's been provided in this sample. And it's not saying there is only one possible correct answer. You might have a structure that's different to this, but having a structure is important. So you'll notice that the top half of the response is dealing with experiment A, and it contains the quantitative analysis there. The bottom half of the response is dealing with experiment B and actually contains two pieces of quantitative analysis there. Okay, so what does the observation show us? What does that mean in terms of the relevant model, in this case, the wave model for experiment A? And this is really key. This supports the wave model of light. So I'm an advocate of somewhere in your question, particularly as you get towards the end of your response, you're going to write something that's going to take your response back to the question itself. So the question was about supporting the two models of light, and you can see at the end of the section A, this supports the wave model of light, and then down here in section B, ideally there'd be something that says this supports the particle model of light. Okay. Calculations relevant to the particle model. Again, the use of the appropriate scientific language. So things like diffraction, interference, dark and light bands, work function, photoelectron, kinetic energy of photoelectrons. Those are the sorts of terms that you should be familiar with from your knowledge of the syllabus. And that's the sort of scientific language you need to weave into your response. So, with all that on board, how does this help? Well, within the book itself, the A+ Physics book, there's module summaries with some hints along the way to help hone your focus in areas and help overcome some of those hurdles that often are traps for the more naive. There's concept maps so that you can construct a bigger picture as to how the key ideas, the key concepts of each of those modules fits together into a cohesive picture. There's working scientifically information to help ensure that you understand those working scientific skills and you can incorporate those into your knowledge and understanding and also into your responses or questions. There's revision summaries for you to go through and act as a checklist to check your knowledge. And there are some practice questions, including some past NESA questions and a range of HSC style multiple choice and longer response questions with solutions and marking guidelines so that you can see the way in which the marker wanted that question to be answered and use that to build a body of knowledge that's going to make your response quality increase. And then we've got a glossary online and the flashcards to help you revise those key ideas. And also we have these practice exams that are part of the A+ series as well. So there's topic tests in there that cover each of the topics from each of the modules, and then 2 complete exams to supplement the other examinations you're able to practice as part of your revision.